Standard enthalpy of formations and reaction. Delta HF is the enthalpy of the formations of a substance that carry out in 1 atm and 25 degrees Celsius. Okay, the standard enthalpy formation for stable form is normally 0, which is, for example, oxygen, ozone, carbon, and diamond. Enthalpy of reaction, delta H reactions, is the enthalpy of the reactions carried out at the standard state of 1 atm. Okay, which is delta H reaction is the summations of the enthalpy of the products minus to the summations of the enthalpy of the reactant, which is M, and M is the stoichiometry of the reactions. For example, we have a reactions between A and B to produce C and D. So delta H reaction is equal to C, small c, and small d is the stoichiometry of the products here. Okay, this is the products minus to the enthalpy of the reactant. Okay, this is the reactant. So this delta HF is from the thermodynamic data. Okay, first we can measure the delta H formations using a direct method. Okay, for example, we have a reaction between the carbon and oxygen. So the delta H reactions for these equations is, okay, delta H of the CO2. CO2 is for the product, 1 mole of products. Okay, and minus to the enthalpy of the carbons and the oxygen. Okay, which is 1 mole of carbon and 1 mole of oxygen. Then the value of the delta H formations is depends only on the CO2, which is O and C is in stable form, which is the delta H for the oxygen and the carbon is equal to 0. So the value of delta H of the reactions is equal to negative 393.5 kilojoule. Okay, we can also measure the delta H formation or reaction using an indirect method. It is because many compounds cannot be directly synthesized from their elements, and there are side reactions produced during the formations of the products. So delta H formation can be determined by indirect method based on the law of heat summations or Hess law. According to Hess law, when the reactants are converted to products, the change in enthalpy is same whether the reaction takes place in one step or in a series of steps. In other words, if we can break down the reaction of interest into a series of reactions for which the delta H reactions can be measured, we can calculate the delta H reaction for the overall reactions. Okay, from the figure, we can see that there are 3 different pathways. First is directly from A to B. So delta H1 is equal to delta H from the A to B. And secondly, we have an intermediate C, okay, which is delta H1 is equal to delta H2 plus delta H3, okay. And then the third one is we have intermediate D and E, which is the delta H1 is equal to delta H4 plus delta H5 plus delta H6. Okay, general rules in applying Hess law. First is we should arrange a series of chemical reactions corresponding to a series step. Okay, when we add a series step together, all species will cancel except for the reactant and product that appear in a overall reactions. Let's say we have an equation A plus B to produce D. Okay, the product we want to produce here is D. So this involves 2 series steps. First is A plus B produce C, and secondly is C plus
Second step is D. So our product here is, so means that we need to add this step A and step B together to produce these equations. Okay, so means the enthalpy of the reactions is equal to enthalpy of the reaction 1 plus enthalpy of reaction 2, delta H1 plus delta H2. And then secondly, if the reaction is reversed, the sign delta H must also be reversed. For example, A producing B, so the delta H is positive 57. So when the reaction is reversed to B to A, so the delta H also, the sign will be changed to negative. Okay, here. Okay, and then thirdly, if the reaction is multiplied by or divides by some factor, so delta H also must be multiplied or divided by some factor. Okay,
Enthalpy of the reaction, delta H reactions, does not depend on the elementary step, but only depends on the final state of the products and the initial states of the reactants. Okay, since enthalpy is the adhesive properties, so the enthalpy will change when the size of the sample change. Okay, means that the enthalpy of the reactions is proportional to the number of mole of the reactant. Okay, let's say we have these equations, which is the delta H is equal to positive 572 kJ. So means that the doubling the molar unit here, okay, will also doubling the enthalpy of the reaction delta H, okay, times 2. So we get this value. Okay, then when we switch the equation from the right to the left, okay, the sign also change, okay, from positive to negative here. Okay, since that the enthalpy is the state functions, so it is the parts is independence. Therefore, it is doesn't matter what is the reactions. We just use to obtain the final reactions.
heat of solutions and dilutions. Dissolving a solid in a solvent will produce a measurable heat change. At a constant pressure, the heat change is equal to the enthalpy change. Heat of solutions or enthalpy of solutions, delta H solutions is the heat generated or absorbed when a certain amount of solute dissolved in a certain amount of solvent. Okay, when more solvent is added to lower the overall concentrations of the solutes, additional heat is usually given off or absorbed. Heat of solution is a heat change associated with the dilution process. If a certain solution's process is endothermic and the solution is subsequently dilute, so more heat will be absorbed by the same solution from the surrounding. Conversely, for the exothermic process, more heat will be liberated if additional solvent is added to dilute the solution. For example, consider the heat solutions of the process in which the ionic compounds is the solutes and the water is the solvent. Okay, what happens when a solid NaCl dissolve in water? Okay, in solid NaCl, sodium and chloride ion are held together by a strong positive-negative or electrostatic force. But when a small crystal is dissolved in water, the three dimensions network of ion breaks into its individual units. Okay, the solution process for NaCl can be considered in two steps. First is the separation of the crystal state into a gas state, which is involve the lattice energy. Lattice energy means that the energy required to completely separate 1 mole of the solid's ionic compound into a gas. In other words, we need to supply 788 kilojoule of energy to break 1 mole of solid NaCl into 1 mole of sodium and chloride ion. And then secondly is the heat of hydrated, which is the hydration of the gas ion, which is heat of hydration is negative quantity for the cation and anion. Okay, by applying a Hess law, it is possible to consider that heat of solutions as the sum of two related quantities, which is lattice energy and hydrations. Okay, delta H solutions indicates that 1 mole of NaCl dissolved in water by 4 kilojoule of heat will be absorbed from the surrounding, which is the delta H is positive, means that the heat is absorbed from the surrounding to the system. Okay, let's consider these questions, how we apply the Hess law. Okay, first is we need to identify what is the reactant, then what is the product that we want. Okay, which is our reactant is graphite and hydrogen, and the product is acetylene. So we need to first is rearrange this equation. Okay, so this is the equations. So since we want to cancel between the each step, so we need to balance the equations. Okay, for the step A, we multiply by 4, so means that the value of the enthalpy also multiply by 4. Okay, for the second, we need to multiply by 2 for the reactions, so means that the value of the enthalpy reactions of step T also multiply by 2. And then for the step 3, we reverse the reactions from the left to the right and from the right to the left, so to produce the product here. So means that the sign will be changed from the negative to positive. Then by applying a Hess law, so we add this 3 enthalpy at the reaction 1, 2 and 3, then we get this value, the enthalpy change of the reactions in the formations of the acetylene. And when we divide by 2, means that the value of the enthalpy also divide by 2. Okay, now we're going to part B, entropy, free energy and equilibrium. In order to predict the spontaneity of a process, we need to know about enthalpy and entropy. Okay, as we know, enthalpy is the quantity equivalent to the total heat content of the system, which is equivalent to delta E for the most process, while entropy S is measure the randomness or disorder of the system. Means that the greater the disorder of the system, the greater the entropy. Conversely, the more order system, the smaller the entropy S. Okay, the difference between the spontaneous and non-spontaneous reactions. Okay, spontaneous reactions are processes that capable to proceed in a given directions without needing to be driven by an outside source of energy. The reactions are favorable when they result in a reduce in enthalpy and increase in entropy of the system. Okay, for example, a sugar can spontaneously dissolve in a cup of coffee, but the dissolved sugar does not spontaneously appear in its original forms. While for non-spontaneous reactions, it is the reactions that does not favor the formations of the product at a given set of conditions, which is the reactions required an energy input or a catalyst to lower the energy requirement to take place. In other words, a non-spontaneous process can only occur if the energy put into the reaction from an external source. For example, the ion exposed to water and oxygen form a rush, but the rush does not spontaneously back into its original ion. Okay, entropy of an object is measure the amount of energy which is unavailable to do works. Which is entropy is measure the number of possible arrangements the atoms in the system can have. Okay, means that the greater the dispersal, the greater the entropy. First is microstate and entropy, which is the concept of probability is useful for predicting the directions of spontaneous process. To do so, let's consider a simple system of four molecules distributed between two equal compartments as shown in figure, which is in A, only one way of arrangement all the molecules in the left compartment, and in B, four ways to have three molecules in the left compartments and one in the right compartment, while in C, there are 6 ways to have two molecules in each of the two compartments. So, means that there are 11 possible ways of distributing the molecules, which is called as microscopic states or microstates. And each set of similar microstate is called as a distributions, which is the distribution C is most probable cause there are 6 microstates, means that 6 ways to distribute the molecules, while for distribution A it is a least possible cause one microstate, which is only one way to achieve. So, in short, the probability that a system will exist with its compartment in a given distribution is proportional to the number of the microstates within the distributions. Okay, since entropy increase logarithmically with the number of microstates, the most probable distribution is therefore the one of greatest entropy. Change in entropy or delta S, which is the difference between the entropy of the final state, which is product, minus to the entropy of the initial state or reactant, which is increase in entropy of the system is result of the increase in dispersal of the energy. Okay, a system with the fewer microstate has a lower entropy, while a system with the more microstates, which is means that they have a large dispersal, has a higher entropy. Okay, for example, in melting process from the solid to liquid, which is delta S for the solid is less than 0, while in liquid delta S will larger than 0. In solid, atom or molecule are fixed position or in orders, and the number of microstate is small. Then upon melting, the atom and molecule can occupy more positions as they are moved away from the lattice point. So the number of microstates can increase because there are many ways to arrange the particles and increase the entropy.
In vaporization process, the entropy of the system will greater than in melting process. It is because in the gas phase, the molecule can occupy more space compared to the liquid phase. For the process which is involving an increase in the number of microstates, the entropy of the system increase, which is delta S, is larger than 0. Conversely, for the process that reduce the number of microstates, it yield the decrease in the entropy system, which is delta S smaller than 0. Okay, if the change from the initial to final result in an increase in randomness means that the delta S is positive, the process is favorable and spontaneous reactions. In solution process, for example, the sugar crystal dissolve in water. As we know that in solid state, there are highly ordered structure, which is the atom and molecule restrict to nearly fixed position with respect to each other. While in a liquid, atom or molecule are freely to move over and around each other. Means that the solution has a greater number of microstates than the pure solute and a pure solvent. Okay, how we want to predict or determine whether the entropy S is positive or negative. As earlier stated, that entropy is often described as a measure of disorder or randomness. Okay, from the solid to liquid, which is solid is more order than the liquid state. Okay, in solid, atom and molecule are confined in fixed positions and the number of microstate is small, which is delta S of solid is less than liquid and gas. So, upon melting, these molecules or atoms can occupy many more positions as they move away from the lattice point. Therefore, the molecule or atom will change from the order to disorder phase to result in increase in entropy because the number of microstate is increased. Okay, then the entropy also increase when one material dissolve in another. Entropy also increase as the temperature increase. As the temperature increase, the energy associated with all type of molecular motions, either transition, rotation or vibration can increase, which is the increase in energy is distributed among the quantitas energy levels and more microstate are available. Therefore, the entropy of the system can increase. Okay, if the reaction produce more gas molecule than it's consumed, means that the delta S will be larger than 0. Conversely, if the number of gas molecule diminish, means that delta S will less than 0. While if there is no net change in the total number of gas molecule, which is either delta S may be positive or negative, but a change in S or change in enthalpy will be a small number. Okay, from the reaction, we can predict either the entropy S is positive or negative. Okay, from the reaction we can see that the reactant we have one molecule gas, while in product there is no molecule gas uh, in the right side. Means that the delta S is less than 0 or negative. Okay, entropy also increase as the number of more gas increase during a chemical reactions. Okay, consider reactions between the 1 mole of nitrogen with 3 mole of hydrogen producing 2 mole of ammonia, which is at the reactant side there are 4 mole gas, while in product there are only 2 mole gas. Means that the number of gas reduce and therefore the entropy also will be decreased and less than 0. Okay, entropy also increase as the complexity of the molecule increase. If compare between the butane and methane, which is butane has a higher entropy than the methane, which is because butane has a more highly structured and complex and has a less disorder if compared to methane. Standard entropy is absolute entropy of the substance at 1 atm and 25 degrees Celsius. Okay, entropy expressed in J per K or J per K moles. We use a joule rather than kilojoule because the entropy value are quite small. Okay, standard state refer only to 1 atm. However, that we specifying 25 degrees Celsius is because many processes are carried out at room temperature. The entropy of the elements and compound are all positive, which is delta S is larger than 0. By contrast, the enthalpy formations for the element in the stable form is at very set equal to 0, and for compound may be positive or negative. Okay, for different states, for example, bromine vapor has a higher entropy compared to the liquid bromine. For the different substance in the same phase, molecular complexity determine which one have a higher entropies. Okay, consider the natural gas, ethane and methane, which is ethane has a more complex structure and more way to execute molecular motions and increase its microstates. Therefore, ethane has a greater entropy than methane. Okay, for the monoatomic gas, for example, helium and neon, which is cannot execute rotation or vibration motions, which is the neon has a greater standard entropy than helium because the molar mass of the neon is greater than the helium. Table shows the standard entropies for some substance at 25 degrees Celsius for inorganic substance. You can see here that the entropies value for solid is lower if compared in liquid and in gas state. As we know that the standard entropy measure the randomness of the molecular or atom. In solid state, the atom or molecule is more arrangement if compared in gas state, which there are more microstate viable in gas state. Okay, consider these equations. The question asks you to calculate the delta S of the reactions. So you need to find the delta S from the thermodynamic data. So given that from the thermodynamic data, the value for entropy for calcium carbonate is equal to 92.9. This one 99.8 and 7.9. So delta S equal to delta S of the product minus to the S of the reactant. So means that 197.9 minus 92.9 plus 39.8. So we can get this value. Okay, you can see here that the value is positive. Okay, consider here which is at the reactant there is a solid and one gas here. So means that the entropy will increase. So that's why the value of delta S is positive. Okay, while for the reactions, we can actually predict uh, whether the delta S value is positive or negative. Okay, which is 1 mole of gas react with 1 mole or 3 moles of hydrogen to producing 2 mole of ammonia. So means that the number of mole decrease from 4 mole to 2 moles. Means that delta S become negative. Okay, similar here, which is we have 2 mole of gas and 2 mole of gas here. Means that there are the number of mole is same at the reactant and in product side. So the change in delta S is small. Okay, because the number of mole is of gas is similar.